Hello and welcome. Over the next few videos, we are going to be taking a look at materials in Unreal Engine 4. Now, as a quick heads up, this particular video is really just a high-level overview of what materials are, how they work, and some important things you need to know to use them in UE4. If you're already fairly comfortable with the concept of materials, you may want to skip this, but I will let you know that we are going to talk about the new physically based approach to materials in UE4, which is a bit different than Unreal Engine 3. So you can skip it and kind of feel around for yourself if you want to, but if you're interested in hearing about how our physically based approach works, please don't skip this video. So first off, what is a material? I think there's a lot of ways you can define a material to make it make sense to the layperson. I mean, because if you were to define a material technically, you would say something like, well, it is a collection of image files and computational instructions that define the shader that is put on a polygonal surface. And that's a way over the top way to describe it. A much simpler way is to think of it like materials in the real world. So in the real world, you have surfaces around you that are made of things like wood, or metal, or concrete, or fabric. And each one of those has a very particular way in which light plays off of it. And in Unreal Engine 4 materials, you can kind of work the same way. You can create a material that defines wood, that has a particular color, including color information like a texture that would define wood grain. It could define how shiny that wood is if it had been polished. And then you can apply that to a surface, and that surface will look like it's made of wood. Me, generally speaking, when someone who is completely new to the concept asks me how I define a material, I like to say that they're a lot like paint. They're a paint that goes across the surface of your polygon objects and literally defines how light interacts with that surface after it's been coated. Now, in the real world, paint generally only controls color. You get some other stuff too, like what the finish. Thank you. I was looking at that word. Well, what the finish is. So, is it a matte paint? Is it a shiny, glossy paint? It could even be like a metal flake paint. There's all kinds of varieties. But in Unreal, the material surface, the paint, if you will, defines a lot more than that. It defines not only the color, but how shiny something would be, whether it has sort of a tactile feel, like lumps and bumps across the surface, whether any parts of it glow, whether any parts of it are transparent or you can see through them. So this is kind of like special magical paint, if you will. Now, in Unreal Engine 4, materials work a little bit differently than they do in Unreal Engine 3. So if you're coming to this from UDK, you already, if you have UDK experience, then materials are constructed in a very similar manner, but the concepts we use to define our materials are actually much different. So in the UE3 days, we had things like diffuse, we had specularity or specular, we had specular power. And diffuse was color, specular would be like your specular color, and then you had specular power, which would literally be the kind of like the size of your specular highlight. So for instance, if you had an object like a sphere, and you had a little shiny white highlight from a light source, having a low specular power meant that you had a really big specular highlight, and as you increased your specular power, you would tighten that up, sometimes to a tiny little point. It's just to get it really small, at times your specular power had to be a really high number, either in the hundreds or sometimes even in the thousands, to get something to look really, really glossy. Now, we've done away with that. So all of this is kind of the old way. The new approach to materials is physically based. That means we define a surface physically and then use that information. So we have, instead of diffuse, base color, which is a much more descriptive name and should mean a lot more to the common person. It literally is the color of the surface. Then we have metallic. Metallic literally defines how metal-like a surface is. Is it made of metal or is it not made of metal? Now, if it's in the real world, I guess I should say, in the real world, you're going to find objects are either made of metal or they're not made of metal. And because of that, if you want your materials to remain physically based, as in like based in the real physical world, then you're going to want to make sure that your metallic value is either set to 0 or, as I'm saying, or 1. And really nothing in between. You can have something in between, but it's going to look like some sort of, alien plastic space metal that's not going to be super realistic. But I just wanted to kind of mention that. Now, aside from metallic, we also have roughness. Let me clean up my G there just a little bit. So roughness controls how rough the surface is. I'm not going to say at the microscopic level, but if you had like a low-powered microscope, it would be a lot easier to see. So I guess to explain this, picture two surfaces. Let's say we have a ball that is made out of glass. And you're standing right in front of it. So here's you, and here's the sun over your head because it's a nice, bright, shiny day. And then also, let's consider a ball that was made out of something that is a lot rougher. Let's say something like chalk, because chalk is actually a very porous stone. And then, of course, here's the same thing. Here's you standing there, and there's a sun over your head. Now, on the glass surface, you would see a reflection of the sun, and then you would probably also see a reflection of you right there on the surface. On the chalk, however, you wouldn't see any of those things. And the reason for that is because of the roughness of the surface. If you were to really zoom in on it, the surface of glass is really, really smooth. So as light comes in, it bounces off at a nice, clean, consistent angle. However, on chalk, that surface is porous and it's broken up. Chalk, when you really, really look very, very closely, is covered in a whole bunch of tiny little holes. That means that light comes in and then it just kind of goes crazy. It gets spread out in a whole bunch of different directions. And so there's no clean reflection of anything. This behavior that I'm defining, or that I'm talking about, is literally what roughness defines for your materials in UE4. So a value of 0 would be something like glass, while a value of 1 would be something that just bounced light to absolute crazy values. So I mean, it would look even more, even less reflective than chalk, I guess I should say. Generally, however, you will keep this between values of around maybe 0.1 at the very low end to, I don't know, maybe 0.9 at the really, really high end. And you can go to 0 to 1, but you should note that metallic and roughness are just scalar values, so it's a single number, and they are literally going to stay between 0 and 1. In fact, a lot of our values are just straight up linear relationships, 0 to 1 now. There's no more things like spec power where you would have to take a value and set it's like 1,000 to get what you want. Everything is kept to the 0 to 1 range whenever possible. Now, these are your 3 most important material properties for just defining a physically based surface. There are several others that we'll get into as we move forward. So we have things that you might recognize from Unreal Engine 3, things like emissive, which is literally whether something glows. We have, of course, normal, so we can assign normal maps if something has lumps and bumps, that sort of thing. So we have all these different values and many more. Again, this is just kind of like a high-level overview. Now, before we jump out of here and actually go take a look at creating materials in UE4, I want to mention one more thing, and that is how color works inside of a material. So you might be familiar with the concept of floating point colors. If you're not, let's just imagine a pixel. So this is my pixel. He's a happy little pixel. And every pixel is broken up into a series of channels. We have a channel for red, a channel for green, a channel for blue, and a channel for alpha. And each one of these channels is going to have a different value for the particular color. Now, red, green, and blue are pretty straightforward. You probably already understand what those are. It's literally just that color. Alpha, if you're new to it, it is how transparent a pixel is. So a value, an alpha value of 0 is transparent, an alpha value of 1 is fully opaque. Now, As an example, if you wanted the color red, if you wanted your actual base color to be red, you would have, for instance, an R value of, just to keep it simple, 1, you'd have a green value of 0, you'd have a blue value of 0, and you had an alpha value of 1, because you want to be able to see the red. You don't want it to be completely transparent, otherwise you wouldn't be able to see it. Now, on the other hand, if you didn't want red anymore, let's say you wanted this to be, let's say yellow, then you would keep your 1 in red, but you'd take your green and you'd set that to 1 as well. So generally speaking, all of your color values are going to be broken up into these 4 channels, and each one of those channels is going to have a value between 0 and 1. So 0 is going to be equal to essentially 0%, and 1 is going to be equal to 100%. So just keep that in mind. Now, there are some exceptions to how this works, particularly with the emissive channel, which again controls how much something glows. So if you wanted a yellow glow that was very intense and actually put out like, a fuzzy bloom on the camera, then instead of using 0 to 1, you may actually want to use values that exceed that. So it wouldn't be 0 to 1 based anymore. You might want something like 10 and 10 in the red and green channels, and that would create a yellow color. So if you had like a ball that was colored like this, it would be bright, bright yellow, and then there would actually be a visible bloom coming off of that by default. So that is a quick look at materials, what they are, a few of the more important materials for our physically based system. Remember, all of our materials are now physically based, and that your most important properties as far as that goes are base color, metallic, and roughness, which we'll be taking a look at when we actually build our own materials. So that's going to wrap things up for this video. Now let's move on and assemble some materials in Unreal Engine 4.